Senior Education Technologies Producer for NASA Goddard and also an Associate Research Scientist at UMBC, University of Maryland, Baltimore campus, and Dan Laughlin. Have a seat, Dan, who is the Program Manager for NASA Learning Technologies. And we've had the great fortune to do some wonderful collaborations with NASA Goddard, but I think I will now turn it over to them to tell you more.
Good morning. It's a pleasure to meet with you to see if we can work out some ways we might end up collaborating together. What I wanted to do was to give you a backdrop on how NASA is engaged in education. Then Dan Laughlin, I think, is going to give you an overview of our roadmap to how we're applying technology to that education. Dave Stroud will talk about some of the efforts we have underway, particularly with the Franklin Institute in Philadelphia. Coming around should be a chart that's headed NASA Education Framework. That's our context builder. If we were to ask why is NASA engaged in education, those three outcomes, outcome 1, 2, and 3 that are on that chart are the major drivers. Because we are a federal agency, we are very responsive to not being duplicative with the U.S. Department of Education, which has the charge of dealing with education needs in general. NASA's involvement in education relates to NASA's mission. And so if you look at the content that NASA is about, our charge is to make that translatable into education environments. And so the framework you have there, if you look at the triangle, the best way to understand NASA's engagement in education is to start at the top of that triangle and work your way down, not to start at the bottom and work your way up. Because if you start at the bottom with Inspire, there are so many kids, so many schools, so many teachers, so many states, that it would virtually be impossible to move outside of Inspire by the time we're finished. So we are very interested in creating what is called a pipeline. The pipeline, in effect, results in employment, not necessarily with NASA, but in NASA-related fields. So if someone might well go to work for any of NASA's contractors, they might well be going to work for higher education institutions in related fields. It's not at all whether we're trying to just create employees for the federal government and for NASA in particular, on the assumption that that flips around rather frequently as to whether there are jobs or not jobs that are available. So we work from that employee category and say, okay, how would you get employees in all of those environments? And from that, you come down the pipeline to the educate category, which crosses over with higher education. In K-12, you go from that educate category to engagement, and from engagement to inspire. So the logical structure is to say if you want to end up with solid employees in any of the NASA allied fields with any of the employers that I mentioned, then you need to be inspiring young people at the earliest ages, but not just inspiring them and stopping there, but then inspiring them in order to engage some of them in order to help them develop the interest in the fields that we relate to, and as a result of that education, then moving through K-12 all the way into higher education and postdoctoral fellowships into the employment rank. So that's kind of the overview of the logic that we have. We are a national agency, so we have liaisons in all 50 states. We actually have staff who are responsible for linking the state departments of education in terms of math, science, and technology, and envisioning how NASA can support the systemic efforts that are underway in the state. The second chart you received referenced the digital learning network. In the past, our typical delivery mode was by having people go out to schools. We actually do have people located in every state. So Goddard, for instance, serves Maine through the District of Columbia, including Pennsylvania, so we've got a 12-state region if we give DC statehood for a minute. That effort, we actually do provide services in every one of those states. We have staff that go to those states. Our digital learning network now looks at how we can provide not just individuals who would travel to a state, but how we could take Nobel laureates, major scientists, and engineers, and actually bring them into classrooms. The digital learning network actually allows us to bring a scientist inside a teacher's classroom for a 10-15 minute lesson as part of the teacher's lesson because we have the equipment able to do that. So Internet2 is really a kind of intriguing concept for us. Our DLN can get a step above, I guess, QuickTime, or it's not quite jerky heads, but it's a little close. Internet2 looks like an option that would allow us to do some serious education. You have a lot of informal, we deal with higher ed, informal and formal education, and so there are a lot of people connected to Internet2 in school environments that it would look like it may make sense to deal with partnerships, which are a critical component of what this is about. So I'm going to stop there in the interest of time so we can get to the core material and turn it over to Dan.
Bob handed out 2 sheets of paper. I've only got about 57 slides that we'll hurry through.
You need help on using technology.
Or overusing. We can jump through these. Bob already gave us the overlay of these elements, so we can skip that one too. I'm with NASA Learning Technologies, and we're part of NASA e-education, the first E for electronic. And we have been tasked over the last year to put together a roadmap with the collaboration of the Federation of American Scientists on how NASA can tie together its digital assets and how we can move forward using educational technology as we transition out of the era of Web 1 and Web 2.0 and towards what I particularly like, which is Web 3D. This is a very good place to talk about that because Internet2 has the bandwidth capabilities to work with 3D Internet instead of the conventional flat web pages. This is just background on our roadmap. These are 3 of the document sources that we put together or that we used as we were building the roadmap. I have to emphasize, this is the e-education roadmap. It is not the roadmap for all of education or all of NASA beyond looking at the electronic assets that we've got, digital assets, and how to tie that together. This will not explain to you how to write a proposal to the Space Science Mission Directorate necessarily, unless you're doing it electronically, which you can see me afterwards with a suit with some money. Then I'm rushing through these because there's a lot. These, for our road, you're going to lose your button privileges. There we go. These are some of the folks that gave us input and were reviewers on the roadmap as we put it together. At the end, there'll be an address for the roadmap. I didn't print it. It is up to 38 pages, and we didn't have the budget to just either print out the roadmap and give it all to you, or let them have oxygen today on the space station. So you'll have to find it electronically. These are some of the folks. Constance Steincolor, if anybody recognizes that name, will give you an indication of where we're going with this. It is immersive synthetic environments that are a key point of the roadmap, and we've got more slides on those, so if you don't recognize it, we'll get there. But this is just to give you an idea what sort of input we had working with the Federation of American Scientists. We did interviews with leaders in their field in immersive environments, evaluations, online technology of all sorts. I think I may have lost him off there. We had John Bransford, but must have been cut off. John is recognized, and I was wondering how to put him in there, as an e-learning guru. And I wasn't sure if that was a recognizable title that we could work with. But these are our experts now. These are some of the groups that have reviewed the roadmap for us. And it is currently, by the way, when we get the address, still up on the net, looking for reviews before we do a final polish to wrap it up and make it finally official. What is this? We're looking at 3D immersive environments, and again, Internet2 gives us the bandwidth to seriously talk about 3D immersive environments. Dave's going to give these out. He'll be here all day to hand this out if anybody wants this slideshow later, so I'm jumping ahead. Why we're using this approach is it lets us tie up the NASA assets that we've got all into one group, lets us establish, as Bob was telling us about the pipeline. Right now, it can be a little bit difficult as you go from one program to another, one document to another. There's not necessarily a connection. We're talking about establishing over the next 3 to 5 years a cyber structure that lets you tie those digital resources together through the immersive synthetic environment that I keep teasing you with. Collaboration. It's a bottom. I think Dave wrote this. We want, even though I talk about this, and even though it's going to look like I'm talking about just having games and immersive environments, I'm talking about tying together through interoperability everything that we currently have on our list of items that could be used in education, from cell phones to PCs, including Bob's favorite, the BlackBerry, and Dave's favorite, the iPod. So that we'll be using those together. I'm going to check. Are there any astronauts here?
One missing?
Maybe. Traditionally, I have talked about this presentation of using a synthetic environment to talk about how when we go back to the moon, we're going to be able to use a synthetic environment, so in an immersive way, millions of people are going to be able to be there to take one small step and thousands of other steps after that and experience the lunar landing. Unlike when I was a child, most of you are too young to remember, I can tell looking around, especially all the women. We watched it on television. Next time it will be immersive, and we hope to even get to the level that we in 2020 have an astronaut in the lander in the same synthetic environment that users on Earth are experiencing. So it won't be just one person, it will be millions of people sharing that. Traditionally, when I talk about that, I say, now how many of you have been to the moon? And in an average room, the answer is none. Last May, I started with, so how many of you have been to the moon? And the hand in the back went up. Later, Buzz Aldrin came up to ask questions about the presentation afterwards, so I have to check now. But hopefully, the next time we get to the moon, we will be able to share that experience, and you will be able to see it in a way that is much better than, obviously we're going to have better footage because we've got higher quality cameras, but that you'll be able to experience a 3D simulation of it in a high level of fidelity that, again, using the broad bandwidth of Internet2, you would be able to move at enormous rates and people could experience that all together instead of just having to watch it on a flat screen. So our pitch that the roadmap is not just for NASA. This is a roadmap that was developed with the idea that there was no way that Bob or other controllers of NASA budget would ever give us enough money individually to do all of the research and all of the work to build the things that we were interested in. So it is definitely a collaborative effort. We need people to do research in different areas. We need them to build some of the structures, build the research tools to look at what we're building with the roadmap, which again goes to the immersive synthetic environment, which we're going to have a very short PowerPoint show really soon. If you'd like a copy of the roadmap, you can find it at that website, or you can ask Dave to take your name and address and send you one. I'm making lots of work for Dave. Or get the slideshow. So no one actually has to write it down, Jennifer.
It's how I remember things, Dan.
Can you open the other picture? Wait. I should be distracting you while Dave does this so no one notices how he fumbles with the keys. Yep. So immersive synthetic environments, you don't get the pictures. My wife went into premature labor. That's where your pictures went. They didn't have them in the hospital. Things are fine, but you get no pictures on this page. Imagine, if you will, really spectacular, amazing pictures that convey to you exactly what the idea of an immersive synthetic environment is. You got that? We are talking about things like World of Warcraft on the game side, and as my boss is here, I have to say it's not all fun and games working at NASA. That we're serious about this. Environments like Second Life, a synthetic immersive environment is one in which the user is situated in a computer screen and they are experiencing the content, as Ted Castronova has put it, as practical virtual reality. It's still through a flat interface as opposed to 3D goggles like we used to think of virtual reality, but it is immersive and then it pulls you in. And it starts with real code. Code building up through to objects. Put the objects in a grid. You get the expansion of that grid in time and space and get a combination that gives you a larger environment. You get a place. Let me know if I'm going too fast. Stick your places together, you get to have a world. And pretty soon you get your world merging so that you get an environment that draws the user in. And for informal purposes, the user is drawn in when they're experiencing this environment and they're talking about the things that their avatar in this environment does as, well, I did this, I did the other, instead of my cartoon character in the pixelated realm did this thing, that thing, or the other thing. They talk about, well, I met Dave at the International Spaceflight Museum last week and we went for a stroll around the rockets. Which the avatar, you may have to look closely at this. One side is the avatar built in Second Life, the other is the picture of the real life user of that avatar. Avatar is your representation in an immersive environment. In case anyone's not used Second Life or World of Warcraft, EverQuest, Lord of the Rings Online, or any of the other millions of user-friendly, well, I'm sorry, millions of users, not millions of options. There's only about 24 options right now. Notice the overlap between real life and simulated life on the bottom. This is a picture, we actually have to update this. Headquarters has embraced the NASA collab and we can drop the Ames out of it now. It's no longer just an Ames project. This is an organizational meeting in Second Life, and most of the pictures here are going to be in Second Life. It gave me the advantage over other immersive environments in that it has user-created content, so I can show you things that were done by folks from outside of Second Life rather than just the coders. Tim Magner's just trying to sneak in quietly. No one look over there. I'm sorry, Tim, did you want to come in quietly?
No, I always think it again.
Cue the trumpets. So this is a NASA collab meeting. At NASA Ames, they have built a facility outside the fence. You may not believe it, but it is hard to get onto NASA centers sometimes and collaborate with with NASA, and their idea is that you can build places outside the fence where it's easier to work with NASA. And some of the younger scientists at Ames had the idea that you could do this in a synthetic environment instead of in a real-life environment, and you could work with NASA through the vehicle of Second Life. NOAA is also at Second Life. They are doing some sort of weather, climate things that use our satellites. There's no one from NOAA here, I can tell, because I didn't get hit by a brick when I said that. Centers for Disease Control are moving into this environment, and there is a very exciting picture of a meeting of real-life government in Second Life, their first inaugural meeting, and if you squint really hard, you can see on the blackboard in the front of the room a PowerPoint slideshow in the immersive environment, because we are working with real-life government and we are not necessarily tapping all of the potential creativity that we could. What you've got is an auditorium, chairs, and a PowerPoint show with a podium in the front of the room, simulated in virtual reality, because that's the most exciting thing we could come up with for a meeting. And the issues are privacy, 508 compliance, and a whole bunch more. And you can see the guy from NOAA over in the far corner is sleeping. It's actually Eric Hackathorn, who has pioneered NOAA's presence in Second Life, and he actually went to a real-life meeting during this meeting, so his avatar went dormant. Now, I'm talking about something more interesting than chairs, and that's moving things into a game direction. And if this is the last computer game you remember, you're going to be a little bit surprised what games look like now. Just a quick bit of trivia, in 1972 when Pong came out, it was not the Atari 2600 that came with the cartridges, so you could load it. Pong was a single console. You got all the equipment and both paddles, and all it could do was play Pong. This is a little bit closer to what we're talking about. This is what games look like now. I've got to change this slide because this is, of course, a single-player standalone game as opposed to a massively multiplayer online game. So it does give you an idea of the quality of the art, and there's nothing wrong with the color on the screen. That kid really is green who is jumping into the pool. A little more creativity there than at the real-life government meeting. So right now, immersive synthetic environments, there's 7 million registered users for the World of Warcraft. Second Life has 5 million users. Any of you who are Lord of the Rings fans will be excited to know that the Lord of the Rings online game comes out in 3 days. So you may be wasting your time here and should be sitting in line at your Best Buy to get your copy right now. They are projected to beat World of Warcraft's record as having the most registered users of a US-based massively multiplayer online game. Also, not on this list because I'm trying to steer us a little bit away from the military aspects. America's Army, which is similar to these games, has 5 million registered users. It's the closest parallel to a government game at the moment. There are overall 30 million, up to 30 million current massively multiplayer online users in this country alone. There are 150,000 computer gamers in this country who are all potential users of the game. And that's why NASA has been indulging me in the idea that this is a tool we can use to reach out and get in touch with an audience that universally plays games and is going to be familiar with a game interface and meet them on their own terms. These may be out of date. These are the 2005 statistics. I haven't asked 300 million people this year what they think. These actually come from the Entertainment Software Association. Virtually all college students get to college with game experience, and so we are talking about massively multiplayer online games as a way to reach that audience in conveniently K20, which is what your particular interest is. That's it. Dave didn't make a nice slide to end them. Okay.
Any questions for Dan as I queue up mine?
Boy,
Congratulations.
thank you.
And thanks for coming anyways.
I have a question for Bob. You said that there is a representative that works with every state.
Yeah.
Are they working with the State Department of Ed? Because this is the first time I was aware of this.
No, the ones I know that I can really answer your question for the Northeast, the Goddard Service Region named to DC. In those states, the staff are responsible for actually meeting with the science, math, and the technology supervisors and understand the state standards. And rather than talk about national standards, actually do the transformation to the state standards so that when they're working, particularly in schools, they're able to provide reinforcement of what the state is trying to do. Because a lot of times the schools are negative on what that effort is. And so when we do something exciting, we're able to say, this is what those standards are about. Not just that. So we actually do create human languages for each of those state departments. And then, but there is a NASA liaison for each of the states.
And how refined who that is?
I can
Well, my turn. My name's Dave Stroud. I'm the Senior Education Technology Producer at Goddard, and some of my jobs that I have are to produce educational media content, be a content developer for NASA education, and in particular the areas of interest at Goddard, which is earth science and space science in particular. One of the other jobs that I have is to identify and leverage emerging technologies as a way of staying ahead of the curve in terms of how to deliver this content. And back in August, a colleague of Jennifer's, Heather Weiss, contacted me out of the blue and wanted to know whether Goddard would be interested in doing some collaborative efforts between Internet2 or with Internet2 and Goddard. And because of my job description and my just own personal interests in life, I jumped on that opportunity. So for me, what I just come to discover with Internet2 is the potential for the long-awaited convergence of media, which is broadcast quality video, multimedia interactivity, and on-demand video as sort of the definition of what the media convergence was about 10 years ago. And as Dan was talking about what the future would hold at NASA with the immersive games, I really see what I'm endeavoring to do is a natural segue into that, particularly when we're talking around 2020. That's my interest. So let me just talk, I put this together and we'll go through these pretty quickly. NASA has 4 major directorates: the Aeronautic Research, the Exploration System, which is what's going to take us back to the moon, the Science and Space Operations. And for our purposes here, really what we're looking at is Goddard's role within science, and we're looking at, just for this particular demonstration, earth science. And earth science, in the earth science realm, is really broken down into the 4 major spheres that you see here. This is what these 4 particular regions of the spheres, or projects within science, choose to study. And you can see the climate variability and change, water and energy cycle, atmospheric composition, carbon cycle and ecosystems, earth surface and interior, and weather. And for any of you that have cracked a textbook on earth science, you will see that this is pretty much an overlay of what you would find in the table of contents as to what would be taught within an earth science curriculum. also within that Earth Science curriculum, and you can see extensions into other areas, that the applications from a NASA perspective are these, with agricultural efficiency, coastal management, disaster management, ecological forecasting, and so on. And this too you would see in a lot of, particularly college-level textbooks on Earth Science. These are the missions, and this is just really half of the missions that currently exist at NASA within their Earth Science. And they're looking at a lot of different areas of the Earth system science. And so as an example, this is basically what it looks like above our head right now, with 20-some satellites that are orbiting, that are looking at different types of data from the surface of the Earth and in the atmosphere. So it's a sensor web. And the sensor web, as a result, and here's an example of one particular satellite that has 4 or 6 different instruments on it that are collecting different types of data that have to do with the hydrologic cycle or the water cycle, looking at land ice, sea ice, precipitation, and so on. And what this animation is showing is that how this satellite orbits the Earth and collects data and of different sorts. So as it is, it's painting the Earth sort of in a backwards way, collecting information. Now, from that is the data goes into a scientific visualization studio where a team of visualizers will take actual data and will then put it into a data visualization that tells a story. And so this is actually from actual NASA data that takes a look at almost every single aspect of the hydrologic cycle. We're looking at the biosphere right now coming up into Europe. TRIM is another satellite that looks at the, which is the tropical rainfall measurement mission. And what's really interesting here is that you're able to take the data that these satellites look at and then visualize them and model them so that you even, like down here on the right-hand side, you can see a hurricane as if it was done as a 3D or a CAT scan. And all of these media are available at the Scientific Visualization Studio webpage for perusal and download. Here's another example of that CAT scan that is produced by TRIM. And what you're looking at is the rainfall measurements as Katrina is going from a tropical storm into the hurricane just off the coast of Florida. So here's a partial list of data products that NASA Goddard is currently producing. So this is this pretty much covers it all as far as data sets are concerned. And as a result, this is a partial list of the visualizations that are being produced out of Goddard. Okay, so that's from a scientific perspective. That's fulfilling the science mission of NASA and particular projects within NASA. Now, this is where I come into it with Bob and other folks within education, as well as my role being part of Goddard Television. And that is that these are the kind of products that are available to everybody, not only educators, but also to the general public. Again, these are hot towers. The hot tower here is an indicator of the intensification of hurricanes just before that it happens. These are really wonderful, very rich data sets that explain a lot of different aspects. Here's another one that takes a look at some unknown hurricane. I'm not sure what it is yet. There are a lot of them, but we're looking at the clouds, and then inside the clouds we see the rainfall as well. Animations are also produced as a way to illustrate how satellites work from an engineering standpoint. This is very helpful also in teaching remote sensing. Also animations that are produced in order to be able to help educators or scientists be able to describe complex concepts either within the classroom or to the public. Here we're looking at an animation about the carbon cycle. So NASA is really full of resources to be able to have the public come and get them and be able to integrate them into pretty much anything it is that an educator would want to do to be able to explain to their class at different levels from K to 20 and beyond, really. The other thing that NASA, and particularly Goddard, is very rich with is scientists. We have all of these visualizations and all the data and so on, but what we have access to is a very rarefied group of individuals, some of the brightest minds in the world who are collected at NASA Goddard working on the cutting edge science and technology. So we have direct access with these, and then in the past, what we've been able to do is ask some very specific questions of these scientists based on concepts that maybe have been taught in the classroom by educators within, say, grades 7 through 12. So they're able to answer specific questions. And these are some of the things that we've done in the past. We've also produced videos. I'm going to skip that now. The project that was born out of starting a relationship with Magpie was a live interactive professional development that took place between the University of Maryland, Baltimore County and University of Pennsylvania. And what it was the Karen Alinich from the Franklin Institute was finishing up an NSF grant to test the efficacy of Internet2 for professional development, live professional development between scientists and teachers. And we put together a show, or a professional development event, in which Jeffrey Halverson, seen here, who is a hurricane scientist, used to be with TRIM, which you saw some of the data sets from. He's now a professor of atmospheric studies down at UMBC. We took him into the green room, or into the studio with the green screen, and just as the weatherman would do on nightly news, he stood in front of it and talked about these data visualization sets live, presented to a group of 30 teachers from grades 5 through 8. And as part of that process, not only was there the live aspect of it, but there were live pre-produced videos that got rolled in at the same time as a way of setting up segments. And I'll talk a little bit about that after this is over. But so, what I imagine here is being able to do a series of these where you could take scientists, bring them into the studio, and do live professional development or professional enrichment sessions between teachers and the scientists. And in this case, what is happening is that this is like a classroom interactive time in which Jeffrey is talking about an analogy between the heat engines inside a hurricane and the engine of a car, how a car works, and going back and forth and trying to make the connections. What's great about Internet2 is that this resolution, which is not even at high definition yet, but of course that's possible, is that Jeffrey can clearly see the people as if they were in the room with him and can call on them. So like, you sir in the salmon shirt, and you would see these people stand up straight, and all of a sudden, they realize that they have to be paying attention. It's not just like a passive television experience, that if this is designed correctly, there can be a real true give and take. And Jennifer was there to learn about hurricanes as well. One of the things that we added on to this is we took John Leck, who is a teacher on loan from Montgomery County Schools in Maryland, and he then presented to the teachers how to go about getting this data, and also talking about maybe some tips of how to use it in the classroom for a conversation starter or an inquiry-based project. And so he spent a little bit of time doing that as well. Okay, so what came out of that is a series of videos. And what I have in mind here is that the project was designed, pre-designed in a way in which, okay, the project was designed in a way in which it could work both synchronously and asynchronously. What I mean by that is that Jeff could present this stuff live, but it was written in such a way that when it was done, it would be broken down into 2 to 3 minute long segments that would respond to a specific topic. And so even though the presentation was a linear narrative, in post-production what we were able to do is produce 35 separate segments that were 2 to 3 minutes long, that a teacher would then be able to go in and choose any one of those and be able to download and use that as a part of a presentation. So, for example, the Discovery Channel has started doing this in Discovery Education, but what they're doing is taking a narrative that has already been done for long form and splitting it down into small segments. And what's unique about this is that instead of producing for the long form, what we're really doing is producing for the short nugget form and putting it together in a way that can be presented in a live synchronous way, but then would be available in small segments asynchronously later. So this is the kind of segment that is produced. And so what's happening here is that by and large, what we have found is that while all these visualizations are available to teachers, they are somewhat intimidated by these visualizations. How can I use this in the classroom? How can I even begin to explain it the way that a scientist does or whatever? Well, what we've achieved here by integrating it into the development is that Jeffrey is essentially explaining a concept using this visualization, and as a result, you have sort of on-the-job training or a reference to be able to go back to as a teacher or as an educator to be able to say, I'm going to use this visualization and I can use it in this way and I can explain it and make your own connections. So this was designed this way, and then we went into post-production as a way of we put a title in the front with a certain look and feel, and in the end we put a little factoid that is just a piece of text that relates to somehow, just a fact that relates to what was just talked about. Okay. So here's the opening, and then it talks about the specific content, and then it will then go back into this. Okay. So the idea here is not only can it be done synchronously, it can be done asynchronously, but after post-production, all of these things can be put back together and be put back into a narrative form. So if somebody were to choose to broadcast it, say either on NASA television or on the Research Channel, you would have a complete program that could be viewed in a passive way. We also had formal question and answer sessions that the teachers would then be able to engage. I wish we had some audio here, but it was a very dynamic give and take situation, and it was fun because they really developed a rapport with one another. in preparing for the production, we went in, we created 4 videos, pre-produced videos, that allowed Jeffrey a break, but also then set up what the next segment was going to be talking about. So in this case, we're talking about how NASA, what tools NASA uses to be able to take a look at hurricanes. Excuse me. So this is basically a mini documentary explaining in an overview form of what was going to be talked about in much more specifics. Okay. So at the end, what we ended up having was 35 segments. We then, after a couple of weeks to allow us for post-production, what we ended up doing is providing the teachers who participated in this the show in segment form, and then all of the data visualizations and animations that Jeffrey used to explain these ideas in raw format, so that you didn't have to show Jeffrey in them. They could be used in any way that they would want to have. And so you can see here, what we've done is with each of the segments, we talk about, give an abstract as to what it is, talk about the media content, give its reference to where it can be found on the DVD, and we made linkages to national standards with each of those. And this is basically what the teacher ended up walking away with, which were all the media resources, all the segments, indexes explaining what they were, and that they'd be able to go back and get this. So what I'm imagining for the future is being able to do professional development, and professional enrichment, being able to do 4-credit classes, sanctioned possibly through UMBC or some other agreement with another university, to be able to have museum interpreters be trained to be able to speak intelligently about these data visualizations, all these other products that they would be having on display within the science centers, among other things. So this was a proof of concept. The proof of concept was to be able to do professional development for teachers. There's going to be another proof of concept that's going to take place between Goddard Space Flight Center and the Franklin Institute to be doing an after-hours adult science education. So it's going to be an enrichment series that's going to be based upon the sun and the study of the sun. And so as far as the next step, technologically, what we're talking about doing is doing high-definition television. Goddard has a brand new high-definition studio, and we'll be bringing the scientists and engineers into the studio, and we'll be streaming it live over Internet2 to the Franklin Institute to a high-definition projector, and have a 90-minute long presentation. And again, the pre-production development, it will be structured in that way so that the participants and anybody else, for that matter, will be able to go to a future website that they'll be able to identify that content and download it and utilize it the way they want. Or very much like the TED Talks. I don't know how many people are familiar with the TED Talks. If you get a chance to go to TED.com, very interesting. Some of the most brilliant people in the world coming to Monterey, to Oxford, England, and giving lectures. And I think that what we would like to be able to do is a similar thing out of Goddard, and getting the science information out into the public at large and have it trickle down into the formal education setting so that we can then align it with the education framework at NASA. So that's pretty much what I've been up to. Any questions for any of us?
So did you have a time frame for the HD programming that you're trying to do?
We're looking at the end of June. And on the docket, on the horizon, there is the possibility of starting a series of lectures with polar scientists having to relate with the International Polar Year. That's something that is sort of in the pre-development phases. And we're also looking at possibly building a larger network specifically aimed at schools and building a network of schools connected to Internet2 and connected to Goddard, NASA, you know, being the operative word there, it's agency-wide, but we're trying to grow this thing.
We have 2 satellites that are up there now called Stereo that today process around the Goddard are being trained. They're ready to produce the first 3D images of the sun. And so that's what we're going to use in the context of Franklin Institute to attract the public and see if we can bring them in after hours in any major way on something.
You know, I know that in previous conversations we've had folks from the Exploratorium here who've been very adept at bringing in huge numbers of people for these kinds of events, and in subsequent conversations there's interest among, you know, many of the libraries that are connected to their state networks and consequently to Internet2. So I mean there are many fora out there for this sort of rich content. It's very, what you are doing is really, really impressive.
Well, that's why it was very exciting to talk to you today and see how much you have to, and how you get it out and how you expand it so it actually ends up being utilized in more world context than national context.
And one of the reasons why we were delayed this morning is we were talking about, you know, how to create ways for individual faculty, museum curators, school teachers to connect with precisely the kinds of resources that you're developing. And I think we're moving this along in our inimitable way, using student volunteers and paid students and so on, that we'll have this kind of infrastructure that will support the broad network that we all represent. So I want to thank you all for coming. We are also, just so you all know, there's a follow-on conversation to this that I'll be participating in along with Jennifer on Wednesday to really see how we can connect the K20 efforts to the work that's going on at NASA Goddard. So thank you.